Alright, for section 3 here in chapter 13, I'm going to be talking about factoring really just kind of some general trinomials, which would be anything that has 3 terms to it, and just kind of some of the rules that we have to follow when it's factoring, whether there's just an x squared or if there's a number in front of the x squared. So, the easy ones are when you're able to factor a trinomial that has a coefficient of 1. So that would be the very first term just says x squared, y squared, a squared, b squared, whatever the letter is that they're using. There's no number in front of it written, which means that there's always a 1 there. And these are the easiest ones to factor. So in order to do that, you want to make sure that the trinomial is arranged in descending powers. So make sure you're going from biggest exponent to smallest exponent. Determine the signs of the second term of each binomial by examining the sign of the third term. So if you see that it's a plus sign so that they're like signs, that means that they're both going to be positive or they're both going to be negative. If you see a minus sign, that means that they're going to be unlike. So one of your numbers will be positive, one of them will be negative. So you have the sign of the larger absolute value of the factor pair matching with the sign of the middle term. So then you write out all of the factor pairs that you see of the coefficient of the third term. And then you select the factor pair that adds to the middle term. And then you write it out as 2 binomials. So you drop the first term. So if it was like x squared, you drop an x into each set of parentheses. And then your 2 numbers that you found that work, that follow kind of these rules, you drop those in the parentheses as well. So let's talk about some examples. So we have x squared plus 6x plus 5. So we are looking for 2 numbers that multiply to 5 and add to 6. So the only factors of 5 are 1 and 5. So if I think about 1 times 5, that would be 5. And then if I add them, 1 plus 5, that would give me my 6. So when I factor it, it would be x plus 1, x plus 5. For this one, when I see x squared plus 4x minus 12, I need 2 numbers to multiply to a negative 12 and add to a 4. So we'll have to have opposite signs here. Now factors of 12, there's a little bit more than just 1 and 12. You also have 2 and 6 and 3 and 4. So the ones that I know work would be negative 2 and positive 6, because if I multiply negative 2 times 6, I get negative 12, and if I add them, I get positive 4. And for the third one here, we have x squared minus 20 minus x. The first thing you would want to do is rearrange it so it's in descending order. So switch that negative 20 and that negative x around. So you're looking for 2 numbers that multiply to negative 20 and add to a negative 1. And the numbers that do that are a positive 4 and a negative 5. Okay, if you need to, in order to remove common factors after grouping an expression, these are the steps that you're going to want to follow. So identify your groupings, factor out all common factors from each grouping, so kind of pull out that GCF again. Examine each term to make sure that there's common groupings, and then if so, factor out that common grouping. So we did see a little bit of this in section 2. Okay, so for these ones, we're starting to get into that process of when you guys are going to have problems where there isn't a 1 in front of the lead term. So for these ones, they actually have it written out as 4 separate terms. So we have mx plus 2m minus 4x minus 8. So what we're going to do is group the first 2 terms together and group the second 2 terms together. So you can see I put parentheses around those. And then I look at each pairing, each set of groupings there, and I pull out anything that they have in common. So in the first set, I can pull out an m, and in the second set, I could pull out a negative 4. So if I pull out an m from the first grouping, I'm left with x plus 2. And if I pull out a negative 4 from the second grouping, it gives me x plus 2. Now when you have ones like that that have negatives, you want to always get the pieces inside the parentheses to match. So if you had pulled out a positive 4 instead, you would see negative x minus 2. So that would be really close to what you had. It just has opposite signs from the x plus 2. So that's why you want to pull out the negative instead. So because I see that I have x plus 2 in both sets of my parentheses, I'm going to grab the terms that are sitting out front, which would be the m and that minus 4, and that gets put into its own set of parentheses. and then you just drop down the x plus 2. And so that is your factored answer. So for this one, I've got y squared plus 2xy plus 3y plus 6x. So again, I'm going to group the first two terms together and the second two terms together. From the first set, I'm just pulling out a y, and from the second set, I'm pulling out a 3. But you can see what's left is y plus 2x, and it's the same for both of them. So my factored answer is y plus 3, because that's what's sitting outside of the parentheses, and then y plus 2x. An additional one here, again, I'm going to group the first two terms, the second two terms. From the first grouping, I'm pulling out a 3x, and from the second grouping, I'm pulling out that -7. Again, watching my sign there. That way I have x minus 3 left on the inside of my parentheses. So final answer says 3x minus 7 and x minus 3. And this last one, again, group the first two together and the last two together. From the first pairing, I'm going to pull out a 2 and an x, and from the second set, I can only pull out a 5. But when I do that, I get in one set of my parentheses x plus 2, while the other side has y minus 3. So because whatever I pulled out does not match, and there's no way to make them match, this one is actually prime. So if you're trying to factor something, and you cannot get the pieces on the parentheses to match up, then you just can't factor it. And so we would just write that it's a prime. So in order to factor any general trinomial that's of this form, ax squared plus bx plus c, we're still going to be using that grouping technique. A, b, and c for these problems are all going to be numbers. And so what we need to do is first make sure that a is positive. So if it is negative, you want to make sure that you change it to a positive. You're going to take the a and the c term, you're going to multiply those together. And you're going to be factoring that number into two pairs, and what those pairs need to do is they need to multiply to that a times c, so that number that you're working with, but they also need to add to the middle term b. And this kind of goes into the rules if it's positive or if it's negative. So then what we do before we jump into factoring is we actually have to rewrite this whole trinomial so that you have 4 terms, just like those problems that we just worked with. And then you start your grouping. So you group the first two terms, the last two terms, you pull out their greatest common factor, you make sure that the pieces on the inside of the parentheses match, and then you should be able to write out your final answer. So let me show you an example here. We have 6x squared plus 19x plus 10. So I'm going to take my a times my b, which would be 6 times 10, which is 60. So I need two factors that multiply to 60, and they have to add to 19. So the numbers that do that are 4 and 15. 4 times 15 would give me 60, and 4 plus 15 would give me 19. So I rewrite my trinomial, so I leave the first and the last terms the same, so you can see I have 6x squared at the front and that plus 10 at the end. What I'm doing here is I'm taking that 19x and I'm rewriting it with that 4 and that 15 that I found. That's the whole reason why I found those. So I have 6x squared plus 4x plus 15x plus 10. Now the order that you put those numbers in does not matter. So if you wanted to switch the 15 and the 4 around, you can. So I group, like we were doing on those previous examples, group the first two, group the last two. Pull out their greatest common factor. So from the first set, I pull out a 2x, and from the second set, I pull out a 5. And again, that's just the numbers and the letters that they have in common that you could take out. Now when I do that, I have 3x plus 2 left, and so then my answer is going to be 2x plus 5 and 3x plus 2. So the problems I was just showing you are kind of leading you into this to kind of get you used to rewriting it and then using that grouping method. Second example, I have 20x squared minus 23x plus 6. So I'm going to take 20 times 6, which is 120. Now I need to find two factors that multiply to 120 and add to a negative 23. The numbers that do that are negative 8 and negative 15. And to find these numbers, you're going to have to do some guessing and checking. Some of that is just going to be calculator work, so you're going to have to just start guessing and checking factors to find ones, and depending on what they are, it might take you a little bit longer than some other ones. And you might accidentally stumble upon it as you're guessing and checking, but once you find it, then you can go ahead and proceed to the next step, which is to rewrite it. So I have 20x squared minus 15x minus 8x plus 6. I group, pull out the common factor from each pairing, make sure that the inside of the parentheses is the same, and so I rewrite my final answer as 5x minus 2, 4x minus 3. For this one, again, start with the same steps. So 10 times that negative 15 would be negative 150. So I'm finding two factors that multiply to a negative 150, add to a 19. The numbers that do that are 25 and negative 6. Rewrite your whole expression here. And then I group them, pull out the common factor, and write the answer. And I would encourage you, I'm not talking through every single thing that I did here, I'm just kind of showing you the steps I did. Pause the video here and see if you can follow what I did and you understand why I pulled out a 2x, why I pulled out a 5. Again, those middle terms, that 6, that negative 6 and 25, it doesn't matter if you switch those around. If you switch them around, you might just be pulling out a different factor, but you should still end up with the same answer that you see here. Alright, so in order to factor any binomial or trinomial or any polynomial, factor out the greatest common factor first if you can, if there are any. Check the binomial or trinomial to see if it's a special product, so those would be the ones that we've talked about in previous sections, like sections 1 and 2. So this goes over if you've got two perfect squares, perfect square trinomial, sum or difference of two perfect cubes, use those patterns that we've talked about. If there is no special product, factor by grouping, and then examine each factor to see if it can be factored further. Check it by multiplying, but I'm not going to be too concerned about you guys checking it by multiplying. That's just something that you could do if you wanted to make sure that you did it right. Okay, so let's take a look at this one. So the first thing I'm going to do actually is pull out a 2x, and so when I do that I have 2x squared minus x minus 3. Then I focus on the piece on the inside of the parentheses. So this is not one of those special products where it's like the difference of two squares or a perfect cube or anything like that. So we're going to have to do our a times c process. There's a typo there. That should say a times c. So you should take 2 times negative 3, which is negative 6. Again, we're looking for two factors that multiply to negative 6, add to negative 1, which would be negative 3 and 2. Rewrite it. Group it, factor out that common factor, and then write the answer. Now the 2x that I have written first, that comes from what I pulled out at the very, very beginning. That was that GCF term. So make sure that you do pull that down and don't forget about that or like drop it off somewhere. So make sure that you keep that out front at all times. And then the 2x minus 3, that's what you factored out. And then the x plus 1 is what was left inside those parentheses. Another one here, factor out a 3, so you get 4x squared minus 9. Now this is a special product, again a typo, sorry about that. So you have the difference of two perfect squares, so this would be 2x minus 3, 2x plus 3. Your answer again, you have to have that 3 in the front because that's what you pulled out first as your GCF. Last one I have here, I pull out that negative 2x for my GCF. Now this is going to be a perfect square trinomial. So again, this was that pattern where you square root the first term and the last term, and you make sure that it doubles in the middle. So if you take 3x times 2, that's 6x, and then you double it, you get your 12x. So these are all special products that we talked about in section 2. So if you have forgotten about those from what we did before, make sure you go back and watch those videos again if you need a refresher on that. So the answer here would be negative 2x and then 3x minus 2 squared. Alright, so check the homework website for the link to the Google Doc that has your homework problems on it. Make sure that you submit your assignment to me in an email, and again, if you need any help or have any questions, please let me know and I can arrange a time to talk to you.